Hello, hello. Welcome back to another video with me, Sai, from Quantum Education. And today we are going to go through another VCEE Maths Methods exam question, specifically relating to the CAS-free part of that exam. So this is question 1 of the 2023 Methods Examination 1. So last year's exam at the time of recording. So in this question, we see something quite typical. Typically, the first question of a CAS-free maths methods exam involves either finding the derivatives or the antiderivatives of functions, more often derivatives, but sometimes you do tend to get anti-differentiation questions as well. So this question has two parts, both of which involve taking derivatives of given functions. So before I actually attempt to solve this problem, I would encourage you to pause the video and give this a try on your own. So let's start with part A. Assuming that you've had a crack at it, let me go ahead and work through my solution to this. So the question says, let y equal x squared minus x over e to the power of x, and we want to find and simplify dy dx, that is the derivative of y with respect to x. So for those of you who may not be familiar with a question like this, this involves something known as the quotient rule. So for instance, the quotient rule says that if I have a function y, which is given by the quotient of two functions u and v, or in other words, this is u of x divided by v of x, then the rule which can be used to determine the derivative of y, which I'll call y dash, which is the same as dy dx. In this case, it can be given by taking the derivative of the first term multiplied by the second function without taking its derivative. So this is u of x, u dash of x, which is the derivative of u with respect to x, multiplied by the function in the denominator, which is v of x, minus the product, but with the product of v dash of x, so the derivative of v with respect to x, multiplied by u of x without taking its derivative. And this whole thing is divided by v of x squared. So it's the derivative of the top, the numerator, multiplied by the denominator without taking its derivative, minus the derivative of the denominator, multiplied by the numerator without taking its derivative. All of that divided by the square of the denominator without taking its derivative. So let's make our identifications here for u and v of x here. So this we can call u of x, the function, the numerator, and the function, the denominator, we can call our v of x. So simply applying the formula that I have written out here, we can work out what the derivative of our function in the question, y, is. So the y dx is simply given by the derivative of u, which is 2x minus 1, multiplied by, which is e of x, minus the derivative of v, which is the derivative of e of x, e to the x rather, which is simply e to the x, times the function x squared minus x, or u of x. So this is x squared minus x. Okay, so, and this is all divided by e to the x all squared. Let's tidy this up a little bit, because all we've done is just brute force applied the formula to the question. So if we tidy this up, we can see that we can write this as e to the x times 2x minus 1 minus e to the x, and I'll take a common factor of x out from the second term. So this is times x minus 1 all over e to the x squared, which is simply e to the 2x. Now, if you're really observant, you will see that there is a common factor of e to the power of x in the denominator, in the numerator rather. So let's take that out and leave the denominator as is. So we got e to the x 2x minus 1 minus x times x minus 1 all over e to the 2x. Now we can use our index laws here. So we've got e to the x and e to the 2x here. So if we use our index laws, we can see that this will result in just e to the power of, so we've got e to the power of x over e to the power of 2x is just 1 over e to the power of x. So we're just left with 2x minus 1 minus x times x minus 1 all over e to the x. And this is the simplified form of the solution to question 1a. So this will give us 2 marks if we show all our working.